Good day. Today we have a short lesson on modeling with regression. Now, the first thing I want to mention, we are talking about these problems as real-world applications. You must be aware of the real-world constraints placed on these problems. Also be aware of extrapolation. That is a prediction outside of the scope of the domain. For example, in number 1, which is the one we're going to do, my domain ends at 5. I really don't want to use a domain of 500 then to ask about what the y value would be. All right. A serious bacteria has been found in the boys' locker room. The biology class has been collecting and recording how many bacteria are found on the locker room door for a week. When the bacteria reach a count of 500,000, the locker will have to be professionally cleaned. The number of bacteria T per day is given below. Now I'm asked to find the model of best fit and the strength of correlation first. So I'm going to open Desmos. I'm going to hit the plus table. Now I'm going to type in my X values, 2 through 5, and 48, 155, 457, 1341, 4062. Now, while it's not a requirement, again, I do like to have a picture of this graph. So I'm going to start my X at 0. Going to 10 is great. Let's start this also at 0 and go up to 5,000. 4,500. Okay, there's my picture. By looking at this diagram, to me this looks like exponential growth. I might be wrong, but at the same time, this gives me a good mental idea of what it might be. All right, I'm going to use the function on the top left, if you didn't see how I did that. What you have to do is click this, turn to, maybe I need to select a pen. Hit that button and it'll pull up regression lines for you in Desmos. It's a very handy feature if you don't want to have to type in the equation. You do need to know that equation though, because I might ask you what it is. All right. Linear, my R squared value is 0.75. Quadratic is 0.974. Exponential is 0.9998. That is really, really close. I don't think we're going to beat it. Not close. And close, but not as close as exponential. So, the model of best fit. Y equals 16.44005 times 3.01446 to the x power. The strength of the correlation, R squared, is 0.9998. This is almost perfect. Compare the model's bacteria count for day 3 to the actual number given in the table. All right, what this wants me to do is look at my predicted model, that would be this line, this exponential function, at day 3. So x equals 3. So the number it tells me I will have of bacteria for my model is approximately, I'm going to rewrite that, is approximately 450 pieces of bacteria. The actual number is 457. This is only off by 7. So this is really close. The last thing is, when will the locker have to be professionally cleaned? Well, it tells me up top after I get 500,000 bacteria. So y equals 500,000. All right, I'm going to go to my wrench, adjust this x or y axis. I get 9.3, so I know it is after 9 days. You should know how to do these regression functions, but now you need to put them into applications problems. So your assignment for today is to try the rest of these problems and submit it for your grade. Okay, that is all I have for you. Have a great rest of your day.